Okay, in this video we'll learn how to find the equation of a line. So for example, let's take any random points. Let's take these two, right? Now, we know a few things from here. We know the points. But what if we didn't know the points? Right? Let's say if it were in X and Y. Let's say if the coordinate was in terms of X and Y. Then how would we solve this? So let's put in x1 and y1 and x2 and y2, right? So what would our slope be? Again, we use the right angle triangle. So this change would be from y1, it's gone to y2, so it's y2 minus y1. And here delta x would be from x1, it's gone to x2, so let's subtract. So our slope would be x2 minus x2, sorry, x2 minus x1. So let's cross multiply both sides by x2 minus x1. So we end up getting y2 minus y1 is equal to m times x2 minus x1. Now we made y2 the subject. We'll get m times x2 minus x1 plus y1. So this gives us our first step to writing an equation. Normally books will represent the slope intercept form if we simplify. As y is equal to mx plus b, where m is your slope and b is your y-intercept. Okay? So for any line that we have, we'll always have this as a straight line form in the slope-intercept form. There are other forms too, but we'll concentrate more on this. So this is our slope. This is our y-intercept. So if I have y is equal to 3x plus 2, my slope is 3 and my y-intercept is 2. Now these slopes can be positive, negative, it can be 0, it can be infinity, right? So let's see the different type of graphs that we get out of it. So if we have 0 slope, so you'll have 0x plus something. So basically anything in this form, y is equal to b, will just be a horizontal line cutting at b. Now if the slope is positive, you'll get a line like this. If the slope is negative, Let's draw it on this thing. If the slope, this is for positive slope, m is greater than 0. If it's negative, then we'll get this dotted line. And it cuts, all of them cut at B. Okay? Now what if B is 0? If B is 0, then you'll get y is equal to mx plus 0, which simplifies to y is equal to mx. This cuts through the origin, so anything of this type will pass this way. Again, if it's positive slope, goes that way. If it's negative slope, it goes this way. And it passes through 0, 0. Now if it's infinite slope, we end up getting a vertical line. And a vertical line will always be x is equal to something, where this point is h. So 4 graphs that we need to remember. Remember, this is always with direct proportion. So the 4, before we go ahead, we'll write the different forms of equation, of writing equations. So the slope-intercept form y is equal to mx plus b, where this is your slope, this is your y-intercept. Then you've got the standard form, where write it as ax plus by is equal to c. So you bring all the a and the b, x and the y on one side, and you take the constant on the other side. And then you've got the intercept form, which is x over a plus y over b is equal to 1, where this is your x-intercept, this is your y-intercept. So these are the 3 main important equations that we'll come across. And if you have the general form, then we bring everything to one side. So ax plus bay plus c is equal to 0. So for this section, slopes are parallel lines. So the slopes will be equal for parallel lines. Look at all the equations. The 3 is the same in this set of equations. The only thing that's differing is the 5, 2, and 0, and that's what makes it intersect at 3 different spots right here. So for parallel lines, you'll always see the slope to be equal. What about perpendicular lines? So you'll use another image. So for perpendicular lines, now what do we see? We see the 3 and negative 1/3. If we multiply these two, we'll always get negative 1. So if 2 lines are perpendicular, the product of the slopes is negative 1. So m1 times m2 is -1. And then lastly, we've got the distance between a point and a line. So if there's a point over here and there's a line here, we want to find out the perpendicular distance between these two. That will determine the distance. So let's take an easy example. So if I have a point over here and a line here, let's say if this is at 3 and this is at -2. So how far is this from here? It's 5 units away. So that will be our distance. Again, if we have parallel lines, how far are they from each other? We've got to find this distance. The coordinates will be given to you, and we can try a few questions.